Now I want to invite Luigi Giuffrida.
Thank you. Okay, hello, good afternoon everyone. I'm Luigi Giuffrida and I'm a PhD student. I don't know. Okay, can you please open our slide? Thank you. So, as I was saying, I'm a PhD student in the Edge group at VLSI Lab, and our supervisors are Professor Guido Masera and Professor Martina, and that is our group. So there is a postdoc, Alessandra, and we, the PhD, that are me, Luigi, Vincenzo, Mattia, Flavia, Valeria, and Enrico, that are sitting there somewhere. So, what do we do with RISC-V and in general in our research? We mainly work on two topics that are hardware architectures for post-quantum cryptography and hardware architectures for AI and machine learning in different flavors and using RISC-V for research in different ways. So, for cryptography, it's part of everyone's life, and it's everywhere. In the last few years, we are moving toward post-quantum cryptography, so a form of cryptography that is able to be resilient against quantum computers attacks, not only classical computers. In particular, with RISC-V, we are doing different. We are having different approaches. For example, we tested the integration of a post-quantum cryptographic function that is KEJAK, an accelerator, in different flavors. So both as a loosely coupled memory mapped accelerator and directly in the pipeline of the core and through the extension interface that the Open Hardware Group's core provide. We are working on a post-quantum cryptography ISA extension of RISC-V, so doing an extension that can support the acceleration and can be accelerated by to perform algorithms in this field. And also we are working on side channel attacks that are a particular type of attacks and to discover, for example, the secrets while they are being processed by the cryptographic algorithm, and we are developing hardware that is resilient to this type of attacks. All of these in a RISC-V context. While for the AI part, let's say, we are working, for example, on a reconfigurable ISA extension supported by a CGRA-like architecture that is RACE, that is reconfigurable arithmetic coarse-grained engine, that is actually this array that you can reconfigure at runtime and decide what kind of operations to be accelerated. Then, okay, Toxos, that is another coprocessor. In this case, the function is fixed and is targeting the acceleration of nonlinear functions in AI workloads. So, for example, all the activation functions and all of that. And also in this case, we have an ISA extension that is supported in this case by the compiler. So you just add the flag and you can get the right assembly code. And also we are working on Arcane, that is a smart data cache and matrix coprocessor that is very easily programmable, and also in this case it's a near memory data cache that you can program through an ISA extension that my colleagues developed. But we don't only do research, we work always in the field of RISC-V. We are active on different international projects. Tristan Isolde, that are our, I see Daniele, that is very proud of that, but also Ricoletto, that is starting in these days, and the SERIX project that Professor Di Carlo before mentioned. In the teaching activities we We also use a lot RISC-V. In fact, I see in the public some guys that did our course. In particular, in this course, the students had the opportunity to try to integrate their accelerators in an open source microcontroller and run all the flow with an open source PDK until getting, as you can see, some, let's say, some more or less reasonable results that are almost tape-out ready. We're missing some parts in the DRC and LVS, but for the next year we will be ready also for that. Then I want to show you one of our biggest achievements at the moment. In fact, in October we were able to submit to participate to a tape-out in 65 nanometers TSMC with this chip Polipo. Polipo features an open source RISC-V based microcontroller that is EXIP, that is a project where we Polito are involved with EPFL and Universidad Politécnica de Madrid, so the equivalence of Polito in Lausanne and Madrid. And with this microcontroller, there are some of our accelerators. So there is KEJAC, that is the one that I showed you before. There is PUFFO, that is a physical unclonable function, always things related to cryptography. ASCON, that is an accelerator always for a cryptographic algorithm. And the streaming CGRA, that is targeting the execution of both nonlinear functions, but also linearities in machine learning models. We are targeting mainly transformers and things like that too. We will see. Because actually, a few days ago, we received the first samples, and we went to the National Institute of Nuclear Physics here in Turin, and this very, very nice girl helped us to bond some of them to a PCB that we found in a drawer. And because we are still waiting for the actual PCBs and the actual package chip and so on, no? But you know, the emotion was so high that we wanted just to try if it was working, and it was working. This is the picture of the bonded chip. You can see there are just few bondings. We were able to bond the JTAG, the one VDD of all the one that we had, and the VDD-IO. So and the clock and the reset, because you know they are important in digital electronics. In the end, we were able to run it, to run the hello world, to run the accelerator. So with this very, let's say, sketchy setup is running. So now we are waiting for the actual chips and the actual boards and everything to actually test them. As you can see there is a picture of my research group that we are very happy and proud of what they did. Sorry. I have to thank, of course, the Edge group and the VLSI lab all, but also EXIP, that is the platform that we used, that, as I said before, is a collaborative platform, open source, and so on. The Embedded System Laboratory and the Chips IT Foundation that helped us with the finalizing, let's say, the backend. I see that there is Davide, that he helped us a lot with the DRC and all the stuff. And also the CERIX Foundation that funded the chip and the National Institute of Nuclear Physics that helped us bond them. Nothing. Thank you for your attention. I leave the stage to Tan.